Hi everyone, my name is Glen from Spartan Solutions. We're a software company with over 15 years experience of digitising industrial operations for companies like Agreco, Atlas Copco, Balfour Beatty and Ramirent. Today I am presenting from my home office just outside of Glasgow in Scotland. Now Spartan builds cloud-based asset performance management software. And as a Profis product manager, I have been invited to speak today about predictive maintenance technology. There are three themes for the panel today. What is the return on investment for adopting asset performance management technology? What is the current state of the art in remote asset management solutions? And how can operators move to pilot and then scale up quickly to full production rollout? The challenge of maintaining plant and equipment in the North Sea is stark. More than $6 billion of unrecovered oil and gas is lost every year due to unplanned shutdowns. And 60% of unplanned shutdowns are caused by topside plant and equipment failure. In particular, gas compression systems, major pumps and power turbines. Every operator of a reasonable size is losing tens to hundreds of millions of pounds per year due to equipment failure. And the problem is getting worse. There was a 14% decrease in equipment reliability in 2018. And at the same time, there was a 3% increase in operations and maintenance costs. And with the pandemic, it feels like a perfect storm is lashing the industry. We now have less people to do more work and massive pressure on cost control. We need a new approach to managing offshore plant and equipment, and now is the ideal time to change. And one well-proven route to change is through the smart use of technology. Now, just over 3 years ago, we started a journey with the Oil and Gas Technology Centre, Strathclyde University and Repsol Sinopec. We wanted to develop a state-of-the-art technology to improve equipment reliability in the North Sea. And we set ourselves 5 goals before we started. 1. The software would be developed in collaboration with rotating equipment experts. Now, one downtime event can easily lead to a £1 million plus production loss. So the software had to support quick decision making in a high pressure environment and be easy to use with less than 1 hour's training. 2. It would support artificial intelligence approaches, from expert rules to complex neural networks. 3. The software would analyse live equipment in real time and apply one or more machine learning models to make sure that we can provide instant warnings of emerging fault modes. 4. The software would live in the cloud so that we could very quickly scale up real-time surveillance to tens, hundreds, and even tens of thousands of instances of plant and equipment. And 5. The software would be open. It would integrate to leading mobile workforce apps, data historians, maintenance management systems, and production loss systems. And it must also support AI models developed by third parties and internal data scientists. And we were delighted to complete a successful pilot of the resulting software, which we call Profis, on the Repsol Sinopec Piper platform. If you visit our virtual booth, we can tell you more about the pilot, what we achieved together, and the lessons that we learned. Profis is now launched as a SaaS software product, and we have kicked off asset performance management projects with companies in the renewables and construction markets. But what is the return on investment of implementing asset performance management for a North Sea operator? Well, our data suggests that around 15% of current production loss can be avoided by preventing or minimising disruption caused by critical plant and equipment failure. If you also include mobile workforce apps, apps that can automate and support work order execution, operator rounds capture, time capture, etc., then you can save tens of thousands of hours per annum of unproductive work. So now we have the technology that can predict and reduce unplanned downtime while making offshore employees more productive. The technology lives in the cloud and integrates to existing oil and gas systems to provide real-time data analysis. And the latest generation of asset performance management software is pay-as-you-use, with simple and transparent pricing and no upfront costs. So the return on investment is easy to calculate, and given the size of lost production every year, is very compelling. So how can you get to pilot and then scale up quickly to a full predictive maintenance solution? Well, it is a lot easier now than it was even 12 months ago. And I wouldn't recommend building your own technology. Only the super majors have the resources to build, pilot and scale out their own software. It's very expensive and it takes a long time. Instead, I would advise using a cloud-based software approach, as they require very little internal IT support. But before you start with the technology, set up a pilot project team. Find a board sponsor, that's very important, an asset owner, probably an OEM, and an onshore and offshore rotating equipment expert. Agree the pilot scope and the success criteria. And once you're ready, the first step is to import your historical data to create a digital twin for each item of critical plant and equipment. The twin is built from a blend of multiple data sources. Data historians such as OZSoft Pi, CMMS records from tools like Maximo and SAP, and PLMS records. You can then connect your live telematics data stream to continually update the twin. The next stage is to implement expert rules as your first wave of AI. Expert rules are quick and relatively easy to implement, and they also have the advantage of being understandable, unlike black box AI models. Once you have a core set of expert rules for the critical equipment on your pilot platform, train the onshore and offshore equipment experts and let them use the system for a couple of months. Assess the impact against the success criteria you set out earlier, and if the results are solid, roll out and scale up from there. The pilot process should take no more than 3 months from a go decision, and it doesn't require an army of data scientists, equipment experts and software engineers to prove the basic concept. And again, with cloud-based systems, it should be straightforward to expand the pilot to more platforms and asset types to provide a full production solution. You can then work with your partners or internal data scientists to develop and deploy more advanced machine learning models. We are currently working with Strathclyde University on an applied research project to slash the time and effort it takes to develop AMM models for topside oil and gas equipment. And this is going to be very important if you want to rapidly scale up across the UK basin. So the benefits of implementing predictive maintenance for topside assets are compelling. And the latest generation of pay-as-you-use, cloud-based asset performance management platforms can be configured in a matter of weeks and quickly scaled across all your platforms. So to me, that leaves one big question, which we can take into the panel discussion. And that question is this: we are seeing early adoption of this technology in other industries such as renewables and construction. So what are the barriers to adoption and rapid scaling of predictive maintenance in the North Sea? Thank you very much for your time.